Hello everyone, this is James Shore with another how-to video. I'm recording this on June 29th, 2015. In this chapter, we're working on creating a reproducible build, and in the last episode, we pretty much finished that up. We now have the ability to type one command and have our build run, and that will work even if we're coming at it from a fresh new installation, new download of the code, which we can simulate by doing a clean here. If we do that, then Jake will rebuild everything for us and then run our build. Jake, of course, is our build tool. This is important because what we want is the ability for anybody on the team to download the code, be able to run preferably just one command and see the exact same results on their machine as we do. And we have come really close to that. There's just one little thing left still to do, one dependency that we haven't accounted for. Now remember, we took Jake, our build tool, and we actually checked it into our source code repository in order to make sure that everybody always had the exact same version of Jake we did, so that when they run the build, they see the same results we do. Now there's another dependency. It's a little bit of a tricky one that will determine how well our code works. And that is, well, Node. If Node isn't installed, then the code won't work, obviously. But more subtly, if Node is running a different version, then the version of Jake we're using may not work. And this is not just hypothetical. This has happened to me when I think Node upgraded from 0.8 to 0.10. Jake stopped working. The newer versions of Jake do not work on the older versions, and I seem to remember that the older versions of Jake don't work on the newer versions of Node. So we actually have to have exactly the right version of Node in order for our code to work. We also need to have Node installed. Now we could check Node in to our source code repository. We could check it into Git. However, that is a really big set of stuff and not necessarily a good idea. So that's something that I'll just put in the README as saying, hey, in order to run this code, you got to install Node, you got to install Git. That's just the way it is. I'm not going to try to make a one-button build for that. But what I will do is say we've got to have the right version. But what happens when we upgrade? What happens when one person on your team wants to use the latest version of Node and they upgrade their machine? How will you know that you need to upgrade yours? Or vice versa, if you change the version of Node, how do you communicate to everybody else on your team that it's time for them to do it? You could, of course, just tell them, but what if you go back to an old version? How do you know that which version of you to use with that? There are different ways of documenting this, but by far the safest way to document it is to automatically check it in your build. And that's what we're going to do next. That is, by the way, this is something called an external dependency. When you have a dependency that you can't check into your source code tree, that is an external dependency. And what I like to do with external dependencies is to check that the correct version is installed and in the build and warn people if it's not. So we're going to go ahead and create a new task called version, which is going to check the version of Node that we have installed. I like to start all my tasks out with a little description of what's going on. So I'm going to say checking Node version. And for consistency, I put in a colon and a dot because sometimes some tools will write out multiple dots as they continue to execute. So if we do that, now remember the way Jake works is we run /Jake and then the name of the task we want. Any task that we can run from the command line should have a description on it. So to show up here with the -T. So let's add description, check Node version. If we had other external dependencies, we might add them to this, and then this would be check, dependency versions or something like that. But I'll just leave it like this for now. So now you can see we can run Jake default or we can run Jake version. I'm going to run Jake version, and there it says it's checking the Node version. To actually check the Node version, we can look at Node's process.version parameter, I think. It's been a little while. I don't know if that's right or not. Let's try it. Yeah, look, there we go. Node version 0.12.4. Perfect. So what we need to do is compare this to the expected version. Simplest possible way to do this would be to just type it, just add a constant here, say expected Node version I like to put my constants in all caps. That's a pretty standard convention. And then we'll say v0.12.4. And then down here, because again, remember v0.12.4 is what we're getting. Down here, we can check to see if they're the same. So we can say expected version, or the actual version is process.version. So in Node, the way you define a variable is with the var keyword. New versions of JavaScript have a new way of defining a variable called let, which behaves a little less screwily than var does, but I don't believe this version of Node supports that yet. Let's find out. No, it does not. So we can't use it yet. We'll just go ahead and use var. So this sets up our actual version variable, assigns it to the results of process.version, standard programming stuff. And then we can say if actual version equals expected node version, or rather does not equal expected node version, then we're going to fail. We're going to say node version doesn't match. I'm going to take out this console log. There's a couple of things I want you to notice here. First off, I'm using this not equal equal statement. In JavaScript, there are two kinds of comparisons. You can say A equals B or not equals B, or you can say A equals B or not equals B. The regular double equals or not equals will actually change the types. It'll do something called type coercions. It will turn strings into numbers and numbers into strings so that you can compare different types of variables. The rules for type coercion in JavaScript are kind of bizarre, and as a result, it's not very safe to use double equals. So as a rule, whenever you're comparing two things to see if they're the same, use triple equals or not double equal like this. It's just one of the weirdnesses of JavaScript. If you're new to JavaScript, just memorize that and do it. It's the safest way to work. So what we have here is if these don't match, we're going to run the fail function with the message node version doesn't match. Fail is provided to us by Jake, just like task and desc are. This isn't a node function. This is a Jake function. If we run this, everything should work because the two versions do match. But let's say that we upgrade and somebody has downloaded this version and they're still on 0.12.4, they should get a fail message. Node version doesn't match. And that's exactly what we get. That is fantastic. It's not very helpful though. What we should do is provide a more descriptive error message. So let's make this into a multi-line if statement. And let's say node version. Let's be a little more descriptive. Let's say incorrect node version, expected node version, but was actual version. Yeah, I like that. That's a lot more descriptive. And that's a general rule of thumb. Whenever you're writing an error message, put all the information you need to understand exactly what happened for debugging purposes into the error message. It will save you a little bit of grief down the road. So that's nice. Incorrect node version, expected 0.12.6 was 0.12.4. That is perfect. And then if it works, one of the rules of a build is if it works, don't say anything. Provide lots of information when it fails. Be very quiet when it succeeds. I put in these messages about what's going on just so you can see that stuff is happening. But other than that, I like my builds to succeed quietly and fail verbosely. So we are almost done here. The only thing is that we want this to run every time we run our build. So we're going to set this up as a dependency. To do that, we're going to add a third parameter. In JavaScript, you can have variable numbers of parameters to your functions. So remember, task is a function that takes a string, which is the name of the task, an optional parameter, which is any dependencies, and then a function as the third parameter that is what will run when that task runs. The way the dependencies work is you just type in the name of the task that must run before this task does. So by doing this, I'm saying to run default, run version first, and then run this function. Now, the neat thing about a build tool is that if multiple things depend on the same task, that task will only be run once. So now if we run Jake, you should see the version dependency run first. There it goes, checking node version, and then it says the build is okay. So there we go. Let's go ahead and check that in. So now our build script checks the node version. Excellent. Now this is good code. I'm pretty happy with this. However, it's not quite idiomatic. And the reason is that in package.json, the npm package.json, there's actually a standard way of saying which version of node we're expecting to use. It's the engines parameter. So this is a JSON file. I don't think I explained this before. JSON is JavaScript object notation. And basically, you put in brackets key value pairs, strings followed by other strings or numbers or booleans, or even other objects, which again are key value pairs. And that's what the engines parameter is, as well as the dev dependencies, which is done for us automatically. So if we look at the package.json documentation, let me just scroll down to engines. Here we are. We could say which version of node we're expecting. This will take a range, but we want everybody on our team to be using the exact same version of node. So I'm just going to put in the exact version we want. So what we do is in that brace, we can type node, colon, and then the version that we expect. In JSON files, the strings have to be in quotes. And the version we expect is 0.12.4, no V in this case. So that's the idiomatic place for putting the node version. Putting it in a Jake file is fine, but it's not what everybody else is going to expect. It's not idiomatic. So I would rather get it out of the package.json. That's a little bit trickier though. What we're going to have to do is somehow pull this information into our Jake file. The way you do that is with the require statement in Node. So let's go ahead and pull this expected version down here and rename it. And in WebStorm, you can use Command Option R to rename a variable and everywhere that it's used. So I'm going to call that expected version. On Windows, you'll use Shift F6. Anyway, now that we have this expected version here, we need a way of getting it out of package.json rather than this string. Let's make sure that that change we just did works. That, by the way, is called our refactoring. We've changed the structure of the code without actually changing its behavior. That does still work. So to get this expected version out of package.json, first we need to get the package.json into a variable. The way you do that in Node is with the require function. Require is something that is built into Node. You can say require and then a relative path to the file you want to require. In this case, we're going to require package.json. And then that pulls this in as a JavaScript object, which means that we can say variable.engines.node to traverse into the variables and get this parameter here. So the expected version is actually going to be package.json.engines, which is this piece right here. It gives us everything in here. And then .node to get the node line out of the engines object. Now that will give us 0.12.4 rather than v0.12.4, so I expect this to fail. Yes, it does, and it failed in exactly the way we wanted, which means that I know what I'm doing this time. At least I'm on the right track here. That's the important thing. As you're programming, if you take small steps and check your work as you go, it's much easier to do things correctly. So our package.json says 0.12.4, Node is giving us v0.12.4. We need a way of resolving that. One way to do it would be to just toss in a v on here. Say that our expected version is v, whatever's in package.json. And in fact, that does work. Let's go ahead and check that in. So now we get our expected node version from package.json. We could take this one step further, and I think we will. There is a library called semver, which is a parser for Node for parsing version numbers that will allow us to check to see if two numbers are equal, regardless of whether or not the v is there. It will strip off that character. To do that, we need to install that module. It's just like Jake. We're going to say npm install semver. We're going to say ignore scripts because we're going to check this into our Git repository, and we're going to save it as a development dependency. So there we go. We've installed semver. We'll go ahead and check that in. There we go. And now we'll do an npm rebuild to see if there's any dependencies that we need to ignore. But as usual, for most modules, there isn't any. Our git status shows that nothing changed, so there's nothing to add to our git ignore. So now we have semver installed, we can require it. Traditionally, you're going to require node packages at the top of your files. It works just like requiring package.json, except we don't put the dot in front. This says pull it out of the node modules directory. If there's no relative path, if there's no dot or dot dot slash at the beginning of the require statement, it will pull it from node modules right here. So now we have semver, we can say, rather than saying if the two things are equal, we can ask semver to do it for us. So here's our documentation. If we scroll down to comparison, you can see that there's a not equal, which will check two variables. So we can say if, let's take this part out, semver.not equal expected version, actual version, then our code will fail. Now if we run that, that should work. It does, and it should work even if we don't put the V on there. It does, and it should fail if we change the version here. And it does. We expected 0.12.5, but was 0.12.4. Perfect. All right. Now, it is possible with semver to put in ranges here, but again, we want everybody on the team using the exact same version of Node, and we want to communicate that clearly. So, because different versions of Node, even bug fix versions, even though in theory they're not supposed to change the behavior of the code, in practice they do. The only way you can be sure that things work exactly the same way for somebody else that they did for you is to actually use the exact same version, down to the byte. Has to be exactly the same. Otherwise, you can't count on it. If you don't have exactly byte for byte the same code, you do not have a reproducible build. And speaking of reproducible builds, we do now have a reproducible build. What we have done here is we have checked our external dependency. We have made sure that everybody on the team is using the same version of Node. And in previous episodes, we got this set up as a one-button build that will automatically rebuild our dependencies when necessary. This is a very, very nice build. I'm going to go ahead and check this in. We've used semver to compare Node versions, and we are done. We have a reproducible build. In the next chapter, we're going to move on to a new topic. We're going to look at code safety and linting, which is a type of static code analysis. In the meantime, my exercise for you is to go ahead and set up your build to check your external dependencies, specifically check that you're using the right version of Node. Try using semver. Take a look at the documentation for semver and see if there's anything else that you like in here, or if you want to improve the output. Play with it a little bit. That is it for this time. Thanks for watching, and I will catch you next time.